There are two directions you could go. There are two directions we could go to generalize. The first is we could look at the next level of complexity being what are called prime powers. So these are numbers where you're taking a prime and you're raising it to a positive integer k. So as an example, you would look at something like 2 to the 1, which is a prime. And you also have 2 squared, 4, 2 cubed, which is 8, 2 to the 4th, which is 16. These would be powers of 2. Or you could look at 3, 9, 27, 81, 243. These would be powers of 3. Or if you really wanted to be fancy, you could look at powers of 5. So you would have 5 squared, which is 25, 5 cubed, which is 125, 5 to the 4th, which is 625. And you could tackle one of these families to investigate. So how many of you would be interested in looking at this? Now, I'm not going to make you calculate phi of 625 by hand. That would be cruel, sadistic, and absurd. Instead, you're more than welcome to use your computer to experiment. So if I look at phi of 3, I know that the answer is 2. And I can start collecting that data and see if I notice a pattern. I could look at 9, which is 3 squared, and I could calculate what is phi of 9. And I get that the answer is 6. And I could calculate phi of 27, and I get that the answer is 18. And I could calculate the next power of 3, which is 3 to the 4th. And it does not do well at all with that. So let me just know that 3 to the 4th is 81. And I get that phi of 81 is 54. So one thing you could do to help us get started on this research problem, because for us it is a research problem. How many of you walked in this morning knowing how to calculate phi for prime powers? So it's a research problem. It's something that you're figuring out for yourself. And it's really good when you do research to experiment, see what you can figure out. So this is one avenue of investigation. Prime powers are one type of number that's just a little bit more complicated than primes. Does that make sense? But there's another avenue you could go down, which is you could look at things that are the product of just two distinct prime numbers. And that's another numerical thing to investigate. So I could say, instead of going with prime powers, I'm going to primes. I'm going to look at the product of two distinct primes. So distinct here means you can't use the same prime twice. So examples of this would be things like 6, which is 2 times 3, 10, which is 2 times 5, 15, which is 3 times 5. And if you just take two different prime numbers and multiply them, this would give you examples to investigate. And then you could look at this and you could say, okay, I'm going to look at what happens when I look at phi of 6 is 2. Phi of 10 is equal to 4. And phi of 15 is equal to 8. And I could just look at these and I could say, now I don't know how to do this. This is a research problem, so it's going to involve experimentation. But when you have a research problem, once you've solved one problem, then you look for what is the smallest bump. So these are two potential bumps that you could go from primes to prime powers, or you could go from primes to the product of two distinct primes. So if you're interested in investigating that, I'd encourage you to do so.